Good morning to all of you. The title of my talk is Nanostructural Architectures and the Biological Roles of 2-hydroxy-3,5-dinitrobenzamide, a BH3 mimetic compound. BH3 mimetic compounds are chemical compounds that are capable of antagonizing anti-apoptotic proteins playing essential roles in apoptosis. Impairment of apoptosis is prime root causes of cancers, and the apoptosis is tightly regulated by BCL2 family proteins. The fate of cells in our system is depending upon the intricate interplay among the family proteins of BCL2 family. The BCL2 family consists of three types of members: pro-apoptotic proteins, anti-apoptotic proteins, and BH3 only proteins. The pro-apoptotic proteins promote apoptosis. The anti-apoptotic proteins resist apoptosis. In this background, designing chemical inhibitors to anti-apoptotic proteins has become an important strategy in cancer chemotherapy. The chemical compound 2-hydroxy-3,5-dinitrobenzamide is a computationally predicted BH3 mimetic compound. In this presentation, I will be discussing about chemical synthesis, structural characterization, morphology analysis, and anti-cancer activity of 2-hydroxy-3,5-dinitrobenzamide, which is abbreviated as HDNP in this study. The schematic diagram in the top panel of the slide outlines the chemical synthesis of HDNP from the 3,5-dinitrosalicylic acid, which is abbreviated as DNSA in this study. The DNSA was first converted into its acid chloride, which was then converted into amide. The bottom panel of the slide depicts difference absorption spectrum and the Gcmr spectrum. As you can see in the slide, the hyperchromic effect of HDNP over DNSA could be attributed to the presence of CONH group at first position of the HDNP, whereas COH group is present in the counterpart of the DNSA. The comprehensive analysis of the fragments ions as screened using NIST library suggested that the molecular ion of 184 Dalton is 2,4-dinitrophenol, and the molecular ion of 44 Dalton is CONH2 chemical moiety in the Gcmr spectrum, as you can see in the slide. Infrared spectra of the DNSA and HDNP are shown in the slide. As you can see, the IR spectrum of the DNSA showed a strong vibration band at 1677 and broad band in the region of 3100 and 2500. This data suggests presence of COH group in DNSA. In contrary, broad band in the region of 3100 to 2500 is absent in the IR spectrum of HDNP, indicating COH moiety is absent. In addition, strong band at 1602 and 3135 suggesting the presence of carbonyl group and amide group in HDNP. This slide shows proton NMR, depth and HSQC N15 of HDNP. Panel A is proton NMR of DNSA. It shows two dispersed resonance representing two aromatic protons of the DNSA. Panel B is proton NMR of HDNP. It also shows two resonance at 8.65 and 8.70 ppm representing the two aromatic protons. In addition, the spectrum also shows three sharp singlet resonance at around 7.2 ppm. Panel C is the proton NMR of HDNP after subjecting to hydrogen deuterium exchange. The absence of triplet resonance at 7.2 ppm suggests that the resonance are due to labile protons of amide moiety. Panel D is the carbon-13 depth of the HDNP. The data depicted two carbon-13 resonance at 125.9 and 131.5 ppm, indicating the HDNP has two tertiary carbon atom. Panel E is 2D HSQC N15 spectrum of HDNP. The HSQC spectrum depicts a single cross-peak at 358.1 of nitrogen 15 dimension and 7.18 ppm of proton dimension, confirming the presence of an amide group in the HDNP. Taken together, the data of HDNP obtained from UV, GCMS, IR, proton, carbon-13 and N15 NMR experiments confirmed the structure of HDNP. The top left panel of the slide shows in vitro cytotoxicity potential of the HDNP by MTT assay. It suggests that IC50 of HDNP against MCF7 was about 500 micromolar. The top right panel of the slide shows the SEM and TEM images of the DNSA and HDNP. As you can see, DNSA was monodispersed, smooth, regular, identical cuboidal projections. In contrary, the HDNP showed discrete rod-shaped particles ranging from 700 nanometer to 2500 nanometer in length and with a breadth of about 100 nanometer. In conclusions, I would like to mention that the HDNP was chemically synthesized, structurally characterized using various biophysical techniques, and morphology analyses were carried out using SEM and TEM methods. The HDNP is a promising seed molecule for developing prototypic chemical inhibitors to the anti-apoptotic proteins. It is very likely that the rod-shaped HDNP could tightly occupy the active site, the BH3 binding groove of the anti-apoptotic proteins. Thank you very much for your attention.